Hello, everyone, and thank you for joining this session. I am Jeremy Tuloup, and I'm a software engineer at QuantStack and also a core Jupyter developer. And today I'm joined with Martin, Madhur, and Thorsten, who are also working at QuantStack. And maybe we can just introduce ourselves when we have the screen, so we have a smooth transition. So I'm going to start by presenting what we have here. So we're going to demo a new project called JupyterLite, which is a Jupyter distribution powered by WebAssembly. And the thing about JupyterLite is that everything runs in a browser. So you can check it out on GitHub, this URL right here, and yeah, and you can also play with it, but maybe you can have a look at it after the talk. So here we're talking about browser-based interactive computing and data science. So what you can do here is that we have a Python kernel called Pyodide, and we can just start and execute code. So it behaves just like a normal Python kernel you would be using in a traditional JupyterLab or Jupyter Classic notebook. But the difference here is that everything is running in the browser. So this idea of having everything self-contained in the browser is not new, actually. So there is a little bit of history about this. For example, this Jive project that was started by Nicolas Bolvec, who contributed a lot to the Jupyterlite project, is also an exploration of how to run everything in a browser. So here we have a screenshot of a kernel using the Python interpreter running in a browser. So I think if you hit that URL, maybe it will just still work. I believe it's still up and running on GitHub pages. So yeah, it's quite nice, actually. Then there was also this other project that I started maybe more than a year ago, but it was more focused on a P5.js minimal UI for writing sketches in a notebook. And this one was taking a different approach by taking all of the JupyterLab components and building something from scratch, while the Jive approach was more about taking JupyterLab and then trying to make it work in the browser by patching things so that they work. So more like a top-down approach here, bottom-up here. And it's also worth noting that there are other projects. One of them is called Baston, that is made by Romain Casati, which is also about using Python in the browser. And this one is actually based on the classic notebook UI. There are also other projects not directly related to Jupyter. Starboard is a well-polished and kind of has this modern look where you can use notebooks in a browser. So it could be for JavaScript, Python, but other languages. And there is also Observable, which takes a different approach. It's more based on reactive programming. It's also very interesting to have a look at those as well. So here we're talking about JupyterLite, which is a combination of these two interfaces, so JupyterLab and RetroLab, that you can use in your browser. So there are a couple of features that are supported by JupyterLite. So here, if you open the file browser, you have access to a couple of files, and those are notebooks. So actually, you have something that behaves almost like a real file system. So you can create a folder. You can go in a folder, and then if you want, you can create a new notebook here, and it will be saved in your local storage in your browser. And there are also other files that come from a server. So those are actually pre-populated, and they're actually served over a plain HTTP server. So the combination of the two are kind of merged, so it gives you this kind of smooth and seamless interaction with files. So if you change something in the interface, it's also saved to the browser storage. So for example, here we have support for themes, so you can have the dark theme, or you can go back to light. There is also this one, which is quite nice and funky. It gives you more like this kind of flashy effects. So all of these are actually normal Jupyter lab extensions, but they also work in light. So that's great. And if you change the theme and refresh the page, the theme will be persisted, so your preferences will be persisted. We also have support for multiple kernels running on the page at the same time. So here we have this JavaScript kernel that we started earlier, but if we open this one, then we see that they show up here, and we can switch between them by clicking on that item here. But we can also shut them down if we don't use them. So it also behaves pretty much like in a normal JupyterLab. And then there are a couple of other features like starting a console. So you can have like a console like this, and then you could do something like this. So this one is running JavaScript. Also renders files just like in JupyterLab. So here you can open a CSV file. You have also JSON for Vegalite charts, images, and also GeoJSON files. So yeah, so pretty much what you would expect. And finally, we also have support for RetroLab, like we mentioned earlier. So here you have this kind of classic look to your interface. You can open a notebook in a new tab, and it gives you this document-oriented UI, and then we can change the language like this if we want. There's also support for display languages. So here I'm switching the interface to French. So we see the menus are in French, and this is saved also in the preferences. So if I refresh the page here, we have all of the buttons in French. So I'm going to switch back to English and go back to here. Yeah, so that's that was a little tour of what you can do with Lite. Like one very nice aspect for this is that it really boots very quickly. So if you go to this repo, so we're actually using this repo here, this demo repo for the talk. And if you click on this, it opens a new tab, and it boots really quickly. So yeah, and this is also by GitHub pages. So yeah, and you can also do it on read the docs. So the nightly build we have on the main Jupyterlite repo is hosted on read the docs. So more on the hosting a little bit later. Okay, so now we're going to cover some of the features, and I will leave it to Madhur.
Yeah, so JupyterLite is based on the Pyodide kernel, and the Pyodide kernel underneath is powered by Pyodide, which was a project by Mozilla, which compiles the Python scientific ecosystem to WebAssembly. And within that, we have also integrated the IPython kernel. So IPython is a powerful interactive shell and comes with its own set of features. And combined usage of Pyodide and IPython gives us the Pyodide kernel, which has a support for lots of features such as redirected streams and error handling, and some of more which we'll see below. So you can see the version of the Pyodide kernel here, and you can, of course, execute all the simple code cells. But since we have IPython integrated, we also have support for redirected streams. So all the standard output and the standard errors. And since IPython is integrated, we also have support for beautiful error tracebacks here. And the support for code completion is also there. So if we press tab here, we see that the kernel here is busy and it's working for us, and we get all the options to complete our code with. We also have code inspection, so you can, let's say, inspect documentation about something, and maybe also access the docstring in the types. Next, we also have support for inputs, but since Python, the Pyodide kernel uses promises underneath to interact with the kernel and the front end. The await keyword is used here. So this is a caveat while using Pyodide. And here it asks us for a value. Let's say my name is Madhur. And then we can access this variable here. And PyPython comes with rich support for displays for all sorts of MIME types. So you have HTML, you have Markdown, you can display pandas, data frames. I'll execute a bit. So here is a pandas data frame. And then we also have more capabilities of the display module. So we can clear some outputs, update some displays. So here we have a screen, a square of, let's say, orange color, and we'll convert it to a square of green color. And here we have hello, and after some seconds, it's gonna change to goodbye. And this is gonna prevent flickering. So we already did discuss about the HTML, but we can also write, mathematical expressions and even LaTeX in it. We also have support for progress bar, JSONs, and in fact, GeoJSONs as well. We can also actually use network requests, and the fetch keyword is actually the JavaScript API for fetching requests. But since Pyodide is compiled to WebAssembly brings Python and JavaScript to the same level. So you can call JavaScript APIs from Python just like here. And you can use SymPy to have mathematical integral expressions. And since we have support for IPython, it also implicitly adds support for magics. So you can do all sort of stuff like all the magic commands, ls and print working directory, and write a file and also show your history. We also have features on interactive visualizations and IPy widgets, and I'll leave Martin to present that next.
Okay, so as Madhur showed you, we did our best to provide all the features IPython provides. So we also did our best to support the interactive visualizations libraries like Plotly, Altair, Folium, and Matplotlib. So I'm going to show you this right now. So when you use Pyodide and Pyodite, you get access to this macropip library, which is actually pip, a kind of pip, but for Pyodide. And you can use it to install a package like that. So here I'm installing Plotly. It will only work with the pure Python packages. So Plotly is a pure Python package, it works, but it will not work if it's a Python library that depends on a C extension and that needs to be compiled. So now that this is installed, I should be able to get a Plotly plot working fully in the browser. So this is really cool. So that was Plotly. Altair also works. If I show it to you quickly. So in order to install Altair, you need to install the wheel to JSON schema. And this might be fixed in next releases. So once this JSON schema is installed, we can install Altair, and we should be able to use it. It's taking a bit of time to install. So yeah, it's installed and it should work. So that was Plotly and Altair. And of course, we support Matplotlib. This is a given. There is a special case for Matplotlib because we provide it by default, just like we provide NumPy and Pandas by default. So it will use some kind of inline backend. It's not really the IPython inline backend for now, but it will behave a bit closely. Using macropip, you can actually install the IPyMPL backend for Matplotlib, and then using the Matplotlib magic from IPython and passing the widget argument, you can have an interactive Matplotlib plot inside Jupyterlite. So you can resize, you can zoom. So this is IPyMPL. I really suggest to check it out. It's cool. Let me just shut down the kernels. So we also wanted to support Jupyter widgets, of course, because they are core packages of Jupyter. So for that, we implemented the communication there is between Python objects in IPy widgets and their JavaScript counterpart. So when I install it and create a slider from Python, I can interact with it. I can get back the value in Python. I can set it to 5, for example. I can display it multiple times. It will be synced between the views. I can also sync multiple widgets together. So here I'm linking the text widget to the slider. So yeah, we have this back and forth communication between the widget, the JavaScript widget and the Python object. So because we support IPy widgets, we should support for free most of the widgets libraries, given that they don't depend on a C extension, for example. So bqplot works. Bqplot is a plotting library based on IPy widgets. You can create interactive plots. And because they are widgets, you can update those plots from Python dynamically, and it will react in the page. So for example, here I've got a line chart. I can change the line chart color. I can change its style. I can also make a bar chart and update the data dynamically with a nice animation. And this is all running in the browser. Another widgets library that I worked on is IPyCanvas. So IPyCanvas aims at exposing the HTML 2D Canvas API to Python. And this is really cool for learning Python because with the canvas, you can do drawings, you can draw whatever you want, and it's actually fun to play with. Here, I created a game of life example. So I'm drawing the grid, and with a for loop and some async IO sleep calls, I can make an animation of the canvas. Okay, I guess I'm going to skip IPyLeaflet for now, but you can check it out if you want. All those notebooks, you can find them on the demo repository that Jeremy showed you. And I'm going to leave the board to Thorsten, who is going to show you how we expose the XUS kernels to Jupyterlite.
Hi. So first, let me explain a bit what XUS is. So XUS is a C++ library for writing Jupyter kernels. It's not a kernel itself, but it helps you to write kernels like XUS Cling for C++, or XUS Python, XUS Lua, XUS SQL, and many more. And we recently showed how to write Jupyterlite kernels for that. XUS is really extendable. So it has 3 extension points. The interpreter, this is basically the interface you have to implement if you write a new kernel. It focuses on a handful of simple methods like execute the actual code or complete the code. Then there is the debugger interface, which is optional if you want to have debugging capabilities for your kernel. And last but not least, there is the server. The server is basically a middleware, which is responsible for sending and receiving the messages from the client. And in this context, the client is the Jupyter server. So the XUS server basically also implements the concurrency model. So basically which things run in which thread. Before we talk about XUSLite, let's have a quick look how this normally works with normal Jupyter. So you have the kernel on the right side, and it communicates with its client, the Jupyter server, via 0 and Q. And in particular, the kernel is also running in a different process normally than the front end and the Jupyter server. But for Jupyterlite, this looks a bit different. So we end up with this kind of architecture. So let me start on the right side. So we have the C++ code for our XUS kernels, and with web and scripting, we can compile this to WebAssembly and JavaScript. The next thing we do is we put this WebAssembly code and JavaScript code in a web worker such that we can use it without blocking the main thread. And then we have a tiny layer of JavaScript or TypeScript code responsible for implementing the Jupyterlite iKernel RP, and this communicates with message passing with the XUS kernel. yeah, and in this way, we can utilize XUS also for deriving JupyterLite kernels. And the first kernel we started with was Lua, XUS Lua kernel. Why Lua? Lua is really, really simple to compile to WebAssembly. So we didn't expect any problems there. And this is why we started with that. And let me show how this works. So here I implemented a game of life similar to the one in Python, but in pure Lua. It has a lot of helper functions. So we will just run all cells. The cool thing about Lua, the whole binary is really, really small, so it loads more or less instantly. And what we end up with is here, also by including some widgets, a game of life, which does not look that nice because we don't yet have support for the canvas. So we're just printing it, but we soon will also add the support for the canvas in Lua. We not only have this example, but also a nice example with widget support. So all the widgets can also be used from this Lua kernel. So I'm going to show a few. So we have sliders, drop-down menus, like everything you want to have in the widget library. And yeah, this can all be used in the browser and is also part of the JupyterLite demo repo. Then we not only wanted to experiment with one language, but see if we can easily integrate other languages or other kernels into JupyterLite. And we choose a maybe not so well-known language. It's called Ren. It's a library you typically use if you want to embed in C or C++ code. And we choose this because it's also really easy to compile to WebAssembly. And we built a tiny package that you can use this for displaying JSON data like this, or displaying LaTeX data or HTML or other meme types. Yeah, so both of these kernels run in the browser and start super fast since they are since the WebAssembly binaries are really small. And now I will give the word to Jeremy again.
Yeah, thanks everyone for these cool demos. So what you can do with JupyterLite also is to share files with someone else. So if you select multiple files and then copy shareable link, you can send the link to someone. And when the JupyterLab will be booting, then it will open these files by default. So that is quite useful, especially with real-time collaboration. So if you're interested in this, you should check out the talk by Kevin, which was yesterday. But the idea here is that all of the work that was put into JupyterLab can also be reused in JupyterLite, with the difference that we use WebRTC as the provider. So you should also check the documentation on JupyterLite to learn how to enable this and how to use it. A quick word on how all of this stuff works. So now that we demoed a little bit like all of the features, you might wonder like, how does this work? So since everything runs in the browser, we still have a need for some kind of server. So here on the left, we have the lab and RetroLab interfaces. But the thing is that they connect to a server that runs in the browser. And by that, we override the fetch and the WebSockets that you find in the browser usually, so that they talk to a special instance of the server. And the server is a Lumino application, which is using the same plugin system as what you have in JupyterLab, which is why we were able to reuse almost all of the tooling already in place for JupyterLab to be able to add extra server extensions such as the kernels we demoed earlier. So there is also a diagram on this on the docs if you want to check it out. Use cases. So of course, the idea is to have something that runs in the browser without installing anything and without having to deal with servers. It's really great for educational purposes because then you can only focus on the content. And here we have some kind of mockup where how this could integrate with GitHub directly. So you could edit a notebook in place. There are also plans to have some tooling to be able to easily export your own website, JupyterLab website, include extensions, themes, and settings. So that is not done yet, but this is just a mockup. With that, you can create your own distributions. So the P5 notebook project we talked about earlier was actually redone recently to use JupyterLite, and here you can customize it a little bit so it's focused on one application. It's the same for iPad which is kind of a custom light distribution as well. And for the deployment stories, we can deploy it pretty much anywhere because you only need HTTP server, like a plain HTTP server. So it could be on GitHub pages, GitLab pages, read the docs, or other like more front-end oriented hosts such as Vercel or Netlify. And there's a documentation for how to deploy your website here. Up next, there will be improvements to the tooling, to RTC. There will be more XU-based kernels. We also try to improve the WebAssembly story and try to reuse the QuantStack tooling to be able to make that easier to use. And there's also ongoing work to make more interactive documentation. For example, with the tools like Theeb, JupyterBook, and CurveNote. VSCode.dev was announced recently, and the VSCode.Pyodide extension is actually using the Pyodide kernel with emotes. So there are also some interesting things we can do here so that it works with VS Code. Later, we might be able to reduce some load on the things like mybinder.org so that the people can start their notebooks in the browser instead. And finally, we will try to make Voilà work also in a browser, so you could create and publish dashboards without having to run a server. So something to watch for the future. And with that, I would like to thank everybody who contributed to the project, and thank you for attending the session.
Thank you. It was a great talk, and yeah, I was switching in between the talk and moderating all the other things. So we do have a couple of questions. Let me start with the first one. Yeah. So Christian asked, "Are you going to describe your build pipeline?" I'm not sure if you went through this.
So we actually use Pyodide directly in Pyodite, so we don't compile it ourselves, the Python interpreter. But I guess, Jeremy, you want to say something more about it?
Yeah, we pretty much reuse Pyodide as is right now, and it's fetched from the CDN if you use the demo. So it's really just a stock Pyodide. One thing that we mentioned at the very end was that we might look into making the package management a bit easier in the future, so that we can compose packages and create our own custom Pyodide distribution more easily with tools coming from the QuantStack ecosystem, for example.
Awesome, thank you. There's a question by David, which goes like, I guess that there is no way to interact with files from the underlying file system. One needs to upload them directly to the JupyterLite directory.
Yeah, for now, that's the case. We need to upload it and download it, but there's an issue open on the repo that we're going to have a look soon, is that we should be able to also use the file system API from the browser so that you can mount a local folder that is on your computer into JupyterLite. So the problem with this file system API is that it's not supported on Firefox, so we didn't want to have that in the beginning, but I think we can make it optional so that if it's available, then people can use it at least in Chrome.
All right. So I have time for only one more question. So yeah, is JupyterLite usable on a recent model of iPad?
Yeah,
the device. Absolutely.
Yeah, as long as your iPad, your browser can run WebAssembly, which I think it is the case on iPad. I mean, it should just totally work. And this is also one advantage, is that you can also run that on low-end devices or devices that have only access to web browser, like a Chromebook also. So yeah, I would say it should work on the iPad. Yeah.
All right, thank you.